Okay, actually, it's a bit warm here, so I must, Advertising, if I'm going to be on camera. Okay, thanks. So my name is Rory Walsh, and I'm going to talk about a package I've written for Unity called, very imaginative title called CsoundUnity. It kind of does what it says in the title. So it's kind of, I guess if it was a true workshop, you'd all be following what I'm doing with laptops and things like that. So think of it more as a walkthrough kind of. What I hope that you might take away from today's talk is if you've never used Unity before, that you'll have a better understanding of what it is as an environment and how you might be able to use it for your own research and fun, enjoyment, and also how you might go about using Csound in this wonderful game engine. So things I'm going to be looking at today. So I'm just going to start the clock here so I don't get carried away. So now, topics to be discussed. I'm going to look at just some of the core concepts in Unity. Then I'm going to be looking at assets, project management, hierarchy, scenes, game objects, scripts, materials and shaders, coordinate systems. So these are kind of the really core stuff that you kind of have to have some idea about if you want to get working with Unity. And then I'll look at player movements, how we can kind of animate players, how we can move objects around the scene. Another important aspect is cameras, because every scene has a camera, and you can move the camera around like you can move a player around, and this kind of stuff. So it's not rocket science. It's fairly basic stuff. We'll be looking at collisions and triggers, kind of how we can use the physics engine in Unity to how we can have two objects collide with each other, and how we can get information about those collisions, how we can get that information, and then potentially use that within Csound. I'll be looking at audio sources and audio listeners, kind of two fundamental audio objects that you have in Unity. And then following that's going to be quite quick and brief. Following that, we'll introduce CsoundUnity. We're looking at setting up and installing, which is quite simple thanks to Unity's package management system. The CsoundUnity classes, it's basically just one kind of master class and a few other utility classes. Triggering instruments and playing sounds, collisions and triggers. So we'll kind of go back to the idea of the collisions and triggers, how we can use that to trigger sounds in Csound. We'll be looking at controlling sounds in real time. So that's kind of the general idea. One thing I say is I've been to one or two Unity workshops, and I've found them quite frustrating because even the last one I was at, the guy I kind of paid a fee to attend this workshop, and the guy said, okay, he said, now don't worry because we won't be doing any scripting today. Like, you don't have to write any code. I was like, I want my money back, this is the reason I'm here, is that kind of, it's just, I don't think you can really use Unity without having, without scripting some stuff as well. And it's, like I said, it's not rocket science, but it really lets you get to the core of the engine. It really lets you get to the core of the functionality. And without some basic scripting, you're not going to get very far with the engine. So, projects in Unity are made up of various assets, and the assets they could comprise of characters, images, audio, 3D models, etc., etc. It's good to have a good project hierarchy when you start your project. So what I'm going to be doing is I'm going to be swapping back and forth between Unity, and these slides will be just to remind me of things that I should say to you guys. So, but mostly we'll be looking at Unity. So I'm just going to, when you start, create a new project, I'm going to call this Csound 30, and I'm going to just throw it in there. Bingo, create project. So you can set between 3D and 2D. Essentially, the 3D and 2D packages in Csound are the same. You just change the camera perspective from perspective to orthographic. So kind of even when you're doing a 2D side scroller or something, you can easily swap to 3D as well. So it's kind of all the scenes are more or less 3D, all games are 3D. How you present the camera angle will determine whether they look 2D or 3D. So you can change it later anyway if you want. Oh, it already exists. There you go. Okay, so when you create a new project in Unity, so I'm going to do all this from scratch, so I'm not going to use any pre-existing material, stuff like that.
Done earlier.
Yeah, there's going to be none of that. Yeah. It's all going to be done on the spot. So I'm going to close this and close tab. So this is the main window, this is the main interface. Here's your assets folder here. The first thing I'd normally do is I'd create a new folder. I'm going to create a folder for scenes. I'm going to create a folder for materials. I'm going to create a folder for, that's funny spelling, for materials. I'm going to create a folder for scripts, which are kind of... So it's a good idea to keep your assets fairly well, structured, or keep that kind of project hierarchy, because as you can imagine, the more and more complex the games get, the more and more organized your assets folder has to be, or else it's going to be a nightmare to maintain. So scenes are important in Unity. You can think of scenes as game levels. Each scene can be different, or you can think of scenes just like, the word itself is a pretty good description of what they are. They describe a particular scene. You could have a different scene for every room that the player moves in and out of, or you could have a different scene, as I said, for different game levels. When you start Unity, it automatically creates a scene for you. So you've got this scene. This is our scene at the moment. I can move around in the scene. We've got nothing in the scene, but the first thing I need to do is I need to save that scene. So I'm going to save it in scenes, and I'm going to call it level 1. Okay, so now that's our scene set up. If I was to create, for example, I can create a second scene. I'll call it level 2. Nice thing about Unity is when you duplicate any of the assets, it automatically appends a number to the end of it, so you don't have to rename it. So if I keep duplicating, I can have scene 3, scene 4, scene 5. It's kind of just little things like that kind of speed up development too. So I'll double click on scene 1 and go back there. So as I said, a scene can contain a 2D or 3D world depending on your project, and you can swap between the 2D or the 3D world, so you can click to go from 2D to 3D. So, but like I said, all games are essentially 3D. It's just how you present it to the user, whether it's going to look 2D or 3D. Lighting is important. Obviously, you need to have lighting in order to take advantage of the different materials and shaders. If you don't put in any lighting, your scene is going to be dark. The main light you have in Unity is the directional light, and you can think of it as the sun that's going to light your scene. I think Unity puts in a directional light by default. There's our light. We can move our light around. If I disable the light, the scene should get dark. So you can see how it changes the scene from bright to darkness. One thing you have when this is the directional light is essentially a game object as well, which I'll come to, but you have an inspector, so a property inspector for different properties of this particular object. So we can see in here we've got the color for the light. We can change the color of the lighting, we can change the intensity, and then we've got things we can control the type of shadows it's going to cast on different objects in the scene. And we've got all that kind of stuff that you can explore in there as well. The lighting is important. There's different types of lights. There's a spotlight, there's a point light, and there's an area light. So it depends on what kind of things you want to use. Like the area light you could use for like street lamps or something like that, because it would just be a little spherical ball of light. So it depends on what you need in your scene. The game object, which I mentioned, the game object class, it's not really a class, but anyhow, is the most basic building block in Unity. Everything is built up from game objects. So a game can be comprised of hundreds, or thousands of different game objects, and you can put them all together to create something called prefabs, or you can just use them as standalone objects. The typical type of objects you've got are like basic primitive objects like squares and or cubes and kind of cones and spheres and stuff like that. There's the game object menu here where you can insert any kind of 3D object. So there's the basic objects you have. Might not seem like a lot, but with some imagination you can put a lot of these together to create more interesting stuff. Also, you can bring in 3D models from 3D Max or Maya or any of those kind of 3D modeling softwares as well. So you can bring them in as assets as well if you want. The game objects, so they make up the scenes, but each game object then itself is going to be composed of different components. So you can add different components to your game object. Adding different components to a game object will add to the functionality of that particular game object. So if first of all, let's see, I'm going to drop in a game object here, a 3D object. I'm going to drop in a plane. This is going to represent our floor. I can zoom in, I can zoom out. I can change the main camera as well. There's a main camera in that scene. I can bring it up so we can kind of see the floor. So what you see down here, this is what the user is going to see in the game. And this is obviously the 3D world. If I play this, we can play them both at the same time. Camera one, here we go. So that's obviously there's nothing happening in the game at the moment. I'm going to turn off maximize or play, so and when I play here now we'll see both. So it's kind of interesting, if you've got a game running you can actually see the kind of editor here, you can see all the different components. It's like seeing, it's like kind of like looking backstage with, on a camera, on a film shoot or something. It's kind of fun. And this is a console log. This just shows you various different things that are kind of flagging different messages. I'm just going to delete those, ignore those. I'm also going to put in I'm going to put in a sphere here. I'm going to drop the sphere in. So one thing about when I dropped in that plane, sometimes Unity doesn't put the plane in the dead center of the scene, so it's kind of, you have to kind of get used to resetting the coordinates so it goes dead center of the scene, because it's a good reference point, 0, 0. And I'm going to do the same with the sphere, so that's going to put the sphere into the dead center of the scene. So now we've got the sphere in there. Problem with the sphere is it's white and it's the same color as the background, so I'm going to just add a material to this. Well, actually, before I do that, well, I think I'm going to get to materials anyway. The sphere, if I click on the sphere again, we can see that it's got a transform, it's got a sphere collider, it's got a mesh renderer, and these are all different components that are by default attached to the particular sphere. If I click add component, then I can add any other type of component. So I can add like physics, I can add a rigid body, which we'll look at in a moment, or I can add some audio stuff. If I go to audio, I can add some audio stuff. So all of these components that you add to a game object will help to add functionality to the particular game object. So, and it's this, we'll see this, so I've written a component called CsoundUnity that we can just add to any game object, which we'll see later on. So, any number of game objects can be put together into prefabs. The thing about the components and all the stuff that's provided by Unity is after a while you kind of you realize that you need to get a little bit more. You need to you don't want it to behave just like the standard component, because it doesn't do everything that you want it to do. So you need to script. You need to start adding scripts. So it's kind of neat. I had no idea what a 3D environment would be like, how you would comprise or how you would combine programming and scripting with some kind of graphical environment like this. But I think it's really neat. You just basically you select an object and then you just add a script for that object. So I'm going to call this ball controller, and that's going to create a C# script for the object. And then I can edit that and I can add different behaviors to that particular script. So the scripts themselves contain instructions on how the game objects should behave and how they're going to interact or move within the environment. And as I mentioned, scripts are really key to developing games in Unity. Scripts can be written in C# or Unity's own Unity script language. It's like a JavaScript. It seems to me that the C# is the recommended way to go with it, and more of the forums, more and more of the answers have been presented in C# rather than JavaScript. And I think it's a tidier. I think it's just a nicer language to use. They're both scripted languages anyway, so they're not rocket science. They're not so difficult to use. So each script you create in Unity will be derived from monobehavior class, and this is the kind of the big class in Unity, and it provides functionality and different methods that can be overridden and stuff. So you can attach unique behaviors to your instrument or to your object. So for example, if I open up this ball controller script, so I'm going to double click it. I use Visual Studio, but there's also, you can use MonoDevelop, which is a kind of, which is another C# environment. If I was working on Linux or OS 10, I'd have to use MonoDevelop because I don't have access to Visual Studio in those environments. But this is the script that Unity generated for me automatically. So it's, as you can see, it's derived from monobehavior, and monobehavior contains lots and lots of different methods and virtual functions that can be overridden. So every script you have is going to have a start method, and then you've got an update method, which is going to be called once per frame. If anybody's done any programming and processing, you're kind of used to the draw method that gets updated all the time. So think of it in the same way. The start method is going to be called when the object is instantiated. In this case, when I hit play, because I have the ball already in the scene, when I hit play, this start object is going to be called straight away. So it's in here that, for example, later on, it's in there that I'll create my instance of Csound, or it's in there that you might kind of instantiate any kind of materials or stuff that you might need for your game. So that's scripts. Obviously, the better you are at scripting, the more mileage you're going to get out of this engine. So materials and shaders then. Materials determine how the surface of the game object will be rendered. rendered. They're going to be dependent on shaders. Shaders are basically scripts that basically tell the engine how to paint all the different pixels onto a material. You can use shaders, you can write shaders that are going to generate data on the fly, or you can just kind of import textures and you can place textures onto objects. So for example, there's standard shaders and materials that come with Unity, so I can double click here, I'm going to right click and create a material. I'm going to change the color of it, change it to red. And if I want to use that material on a particular game object, I can just drag it from this view, and I could, for example, I can place it on the floor, or I can place it on the ball. I'm going to place it on the ball in this case. So you can have different types of materials. For example, there's physics materials as well that will add, for example, if I wanted to make the quad slippery or something like that, I'd add a physics material that would, and I'd set the friction levels and stuff like that. So if I had a character on screen and they stopped suddenly, they'd slide a little bit across the floor. So there's all sorts of kind of neat things like that as well. By the way, if anybody, because it's kind of, this isn't really a talk and it's not really a workshop, so if anybody has any questions, just please shout and ask. Or if you want, can you do this or can you do that? I'm happy to take questions at any point. So coordinates, another important thing in Unity, the two coordinate systems used are local and world space. And they can be a little bit confusing at times when you're trying to script movement for a particular object. So when moving an object around a world space, its x, y, z coordinates are absolute values. So we can drag and move an object around a world space, as in, so I'm just going to click on top here, I can move this object around, and we can see the transform over here, the x, y, z, being updated as we're moving the object around in world space. So if I was to rotate that object, if I were to rotate the object this way, I'm rotating the object in local space, right? And that's relative to the actual game object itself. I guess one way of describing it would be if you all went outside and picked up this room and turned it around while I was still standing here, I'd be moving in world space. But as I do this, I'm moving in local space. That kind of makes a little bit of sense. But so the rotation and scale are always set up to be local space, and position is always set up to be world space. But it's just something that you come across time and time again. So that brings us to the idea. So at the moment we just have a sphere. It's on a plane actually, but we don't have any way to move it. It's not animated in any way. So the best way and the easiest way to animate an object is to add a script to the object. So I've actually already added a script to that object called ball controller. So I'm just going to use that script. To move an object around the screen, there's two approaches that you can take. You can go down the physics route. You can use the physics engine in Unity. Or you can use the character controller kind of approach. So, and each of them kind of have their own pros and cons. So to use the physics engine, you must add a rigid body to the game controller. So if I add a rigid body to the game controller here, or the game object, so I've got this ball, I'm going to add a component, I'm going to add physics, and I'm going to add a rigid body, okay? And we can see in the project inspector now I have this rigid body. We see now I've attached a particular mass to the object. It's got an angular drag, it's got drag, I've got use gravity checked, so it's going to have all these kind of external forces acting on it. If I play this game now, the ball, let's say for example if I move this, I'm going to bring the ball up here and see when I play it's going to drop to the ground and it's just going to stay there. So the gravity is pulled it towards the ground, the ball has a particular mass, and this kind of stuff. So this is kind of one way. And then if I want to move this ball now, I can just apply forces in a particular direction. So that's what this script here does. I'm just going to copy and paste this because it's easier than typing it, but I'll talk you through what's happening. So what we have here is, the first thing is when we create a script, a nice thing about Unity is every time we declare a public member, so I've got a public variable here called speed. When I save this script and I go back to Unity, so every time I save it, I go back to Unity. When Unity gets focus again, it compiles that script for us. You can see this little thing, that means it's compiling the script. And we can see here now that we have access to this particular variable. So we can pass the value of this variable. So while the game is running, I can manipulate the value of that variable, which is kind of neat because it means you don't have to go back to the script and kind of change stuff. So that's kind of one thing I quite like about this particular interface. One thing I'm going to do with this ball at the moment is make it just a little bit smaller because otherwise I have to make my world bigger. So I'm just going to change the size of that ball for a second. So yeah, that's a kind of nice thing. So every public member variable you have will be available to you over here. So it's kind of nice. If I go back to this, so then in the fixed update function, which is going to be called once per frame, I created another variable called move horizontal. It's using this input method. Input get access horizontal is basically going to retrieve every time you press the left or right buttons on the keyboard. It's going to give you a positive or negative value depending on whether you're pressing left or right, and it's going to go between -1 and +1. And it's the same with the input for the vertical as well. That's going to be the up button and the down button. So what I'm doing is I'm creating a new vector tree. It's just a vector, a three-dimensional vector, and I'm applying the movement on the x-axis to this x-axis, so it's x, y, and z. The y-axis I'm not moving at all. I don't want to apply any information to the y-axis because the ball is, when I push forward, I want the ball to go, or when I push up, I don't want the ball to go up in space. I want the ball to move forward. So that's why I'm leaving the y-axis as is. And then the move vertical. So as I said, the vertical is going to control the z-axis. So the best way to think about the coordinates as well, I find, is so you've got like kind of, if you go x, y, and then z this way as well. So if you're ever stuck about which axis is what, that's a kind of a good tool. And then I'm going to apply some force to this rigid body. One thing up here as well is I've declared a class, an instance of a class called rBody. And the first thing I do in the start method, this is like the initialization method, is I call this get component. So using get component, I can retrieve any of the components that have been attached to the game object. So I can start querying like how the user set up the rigid body, or I can ask them about the audio stuff, or anything that's been added as a component. I can access them, I can manipulate in my script. So I'm doing that there. I could also just like do get component down here. I could just type get component rigid body, but actually the more times you're accessing that, the slower, it might slow the game down a little bit, because this has been done every, depending on the refresh rate or the update rate, the frame rate of the game, which could vary from 25 to 48, whatever. It's kind of variable. So you don't want to be doing stuff that's really CPU intensive in there, yes?
Where is the input coming from?
From the keyboard.
Yeah, I know, but like in the program there, is it an object in your class?
It's an object in the mono behavior class, yeah. Yeah. So the mono behavior class is really, that's every game object is derived from that, and then it's got all these member classes as well, kind of like subclasses. Yeah.
Might be worth mentioning that there's some settings where you can set which kind of.
Yeah, that's right. So if you go to edit project settings, input, axes, and then like horizontal, so it says left and right button. So I can use, so for example, if I had I was going to say a microphone, but a joystick.
Yeah.
I'm still in the audio world. I have to get back to the gaming world. If I had a joystick, I could map it and stuff like that. So, and then it would be automatically mapped to that input get axis function.
And then you can get it there.
Yeah, yeah. So once I save this, once I go to that's saved, and now I play this game again, the ball should drop off the screen, but now, whoops, now the ball has gone off the back of the screen. I can maximize this just so we see it. Actually, before I do that, so you saw there that the ball moves quite fast. So, and then it's kind of whoa, and then it's gone again. This is the first game I built. I literally played it for 6 hours. So the nice thing is, so when I play this game, we can still click on the ball. I can click there, and I can actually slow down the speed as the game is playing. So I can just kind of make this smaller. So I just type in 10 here. And then I can now click here, and then so the ball's going to move much slower. But you see in the game editor as well, you see how the axes are rotating because I'm just literally pushing the ball around with different forces. Okay. If I change the mass of the ball, obviously then you've got to deal with there's going to be different inertia, so it's going to take a little bit longer before it gets moving. It's also going to take a little bit longer before it stops and changes and stuff like that. So that's one simple approach to moving objects around. Another approach is, and for this one I'm going to just go to my second scene, so save. Okay, I'm going to put in another 2D object, I'm going to put in another plane, and then I'm going to drop in, come back. I'm going to drop in a 3D object, I'm going to drop in a capsule, and I'm going to change the 0.5, I'll leave that on 0.5. Okay, and I'll change this point 5 as well. Right, so I've got a capsule on this scene. I'm going to drag it upwards, right? So this is going to represent the player, if you like, okay? I just said I'd use a capsule instead of a sphere because it's more like a body of the player or something like that. So that the other approach then, as I said, is to use a character controller. So a rigid body, and often a rigid body is a little bit overkill for, like, especially like a simple like side scroller or a simple platformer or something like that, because in a game like Mario, which, you know, breaks all the rules of physics anyway, you don't really need to try to mess with physics, you know, just use a different approach. And in this case, it's often better to use what's called a character controller component, which is kind of, it's one of the standard components that you can get with Unity. So in order to use a character controller, simply add one as a game object, but don't forget to remove a rigid body if you have a rigid body, because the game controller and the rigid body, they won't play together nicely. So you'll have all sorts of strange things happening, and all sorts of kind of weird behavior, and kind of, you know, going wondering why is this guy slipping down a hill? He shouldn't be slipping down a hill, and all this kind of crazy stuff. So don't forget to uncheck one if you're going to use the other. So once you have a character controller added, we can use a new script, and we can use a method called character controller simple move method, which is kind of easy to use. So here I'm just going to grab this code. So I'm not going to forget to create a new script for this particular capsule because I don't have a script in this capsule. So I'm going to create a new script. I'm going to call it capsule controller with a capital O. I'm going to double click it, reload all. So I can see all these assets that I have, they're all accessible here. I can click through the different assets that I have, so all the scripts are available there. I'm going to paste this in. Now, if I try to run this, I would get an error because I don't have a character controller component attached to my game object yet. So if I come back here and if I try to play this, I would get an error. So I'm going to add I can show you what an error looks like. You'll see the error appear down here, and it says missing component, missing component, missing component. And of course, that's going to be called the amount of frames you have, you know, every second. So you probably need to add a character controller. It tells me, I know. So I'm going to go to physics again. I'm going to add a character controller. So this is going to add a character controller to this particular object for me. I'm just going to make sure that there's no rigid body attached, and I'm going to save that, and I'm going to play it. And now I can move this guy around, so I can walk him around. Oops. It's a lot easier to manage this guy because he's not playing by the laws of physics. So once I stop, it stops immediately. You can still set kind of down here if you go to the character controller. You can minimum move distance. You got stuff like that. You got slope limit. You got step offset and all this kind of stuff. So that you can still have a little bit of control over this. The idea would be that you might get an asset designer to create a 3D model that was some kind of animation, and then you just drop a component, a character controller onto that animation, and then you can use that to move the character around. So that's the two different approaches to movement in Unity. Each has its own kind of unique advantages and others disadvantages sometimes as well. So this brings us to cameras. At the moment we're moving our player around the screen, but the camera doesn't follow the player, so it's kind of a bit silly because you can actually go out of the way of the camera. So every scene in Unity obviously has to have a camera because that's how the user is going to see what's happening in the scene. Unity is going to create a camera on every scene that you have. But you can manipulate the camera and you can move the camera around just like you would any other game object. It's kind of neat because you can have like kind of, you know, zoom in or you can zoom out and stuff like that as well. Each camera has a view frustum, and that's going to determine what the user can see basically on the screen. So it's going to determine the field of view. When you can change the field of view, you can zoom in, you can zoom out. You've got a far field and a near field. And between the far and the near field, you'll be able to see everything that's in there. If an object goes outside of that field, you won't be able to see it. The nice thing is, if an object goes outside that field, the engine will stop rendering it, so it's not going to waste CPU resources by rendering lots of stuff that's not on the screen. So it kind of looks after that automatically. The two different type of camera modes you have in Unity is the perspective camera, which you're going to use in all your 3D scenes. And the further away the camera is, the smaller it's going to appear. So that'll give you a 3D kind of dimension or 3D feel. And then you got the orthographic camera, and there's no sense of perspective. So in this, the lighting changes as well, the shadows are kind of out the window, so when everything becomes kind of like, it's like isometric mode. And again, the camera has its own particular inspector window, property panel inspector, and you can change aspects of the camera in there as well. So if we go back to our scene and we click on the camera here, I'm just going to go sideways because the camera I know is over here. So as I move this up or down, we can see how it's going to change. And we also see that the camera has a simple transform here as well. So obviously we can write a script to move the camera around. We can change the field of view, so we can make it wider, we can make it we can zoom in or we can zoom out. And then if I change from perspective to orthographic, now we get rid of all that 3D information, it's just a flash. So this is what you'd use orthographic if you were creating some kind of a two-dimensional game. I'll show you some stuff later that uses orthographic camera angles. You've got the depth here as well, and you've got different kind of target textures. You can apply texture to the camera as well, so lots of kind of interesting things you can do there. So I'm just noticed that my two scripts are now outside the scripts folder, and I was harping on earlier about project hierarchy, so I'm going to put them into the scripts folder now. So when you do that, if you change any of the scripts, go back to Visual Studio, and if you just say, look, something's changed, do you want it? And you can just hit reload, and you should have all your stuff still there. They're just now going to be in the scripts controller or scripts folder. So as I said, the issue with the scene at the moment is the camera doesn't move with the player. So I'm going to go back to my first scene. I'm just going to save that scene, go back to my first scene with the sphere, and I'm going to add, so I can just add a script to the camera, a new script. I'm going to call it camera controller, unless anyone has a more imaginative name. I suppose you can call it, I can call it whatever I want. I can call it, actually, I can't call it whatever I want. I can call it mono behavior, or I can call it one of the reserved class names, because it'll say our player controller or something like that, which is a reserved class as well. So I'm going to call it camera controller. And so I'm going to double click that, open up camera controller. So what I want to do here is show you how we can have information from another game object and how we can access that in our script. So what the idea here is I'm going to use the coordinates from my ball to control the position of the camera. So I'm first going to do public. I thought there was a stool around someplace. No, but kind of a high stool. I'll just squat down a little bit. So I'm going to create a game object, and I'm going to call it ball. That should be game object ball. Okay, when I save that again, if I go back to Unity, I now see that this script here has a new field, if you like, and it says ball, and it says game object, and at the moment it says none. So what I want to do is I want to drag the ball into that field. I can click here and it'll list all the game objects that I have. It should list all the game objects that are in the scene, sorry, there they are. Or you can just basically drag the sphere and put it in here. And that means now when I go back to the script, this member class here of type game object, which is called ball, that'll give me all the information I need to know about the particular ball. So I can do something in here in update. I can do transform position equals new vector tree, and then I can, so for example, what am I trying to do here? I'm trying to move the camera. Let's just say I want to go across the X and Y axis. So I can do ball, transform, and I can get the coordinates of the ball. It's X position, and I'm going to, let's say I don't want to do anything with the Y position. I'm just going to leave the Y position at what it is, which is transform position Y. So the first coordinates that I put in are the X coordinates of the ball. The Y coordinates are the Y coordinates that are already attached to the camera, because I don't want to be changing up and down. And then the Z coordinates, I'm going to use the ball position again. Transform position Z. Okay, so now when I run this, we should have a camera that now follows the ball. Okay, so I'm just going to save that and run it. Oh, whoa. this camera, oh, its camera's up here anyway to begin with, so let me change the camera X, should be over there. That's the camera. So its Y position is 3 and its X and Z positions should be the same as the sphere. The sphere is up there at the top. I'm just going to bring the sphere down. Onto the ground. And play. Okay, who can spot the problem? All transform.
Is your camera facing the wrong way?
Huh?
Is the camera facing the wrong way on image?
Is the camera angle wrong to begin with? Let's reset the camera. Oh, that's the sphere. Let's reset the camera angle. I did move the camera around, so I'm going to reset the camera. And now I'm going to drag the camera back a bit and up a bit. Okay, that's the wrong direction. If that's the view field, I play. And then I'm going to drag it up and then play it. Okay, now it should move left and right. Yeah, so you can see the camera in the bottom. So actually I'm a bit close to the camera as well, so I'm going to come back on the Z axis, or I can just actually pull the camera back a little bit further as I play it. Still don't see the ball, but you can see the camera, you can see the, yeah, I just move out. You can see the camera is changing now with the ball as well. The other approach you can use is there's a smooth follow script that you can use if you're using the game controller or if you're using the character controller. So if I go back to my scene with the character controller, I click this, there's a smooth follow script that you can import. So if you go to import package and you go to utilities, or utility, here's a load of different scripts that you can attach to any game object. I'm just going to unclick most of them because I don't want to bring them all in. And somewhere down here there should be a simple follow, smooth follow. So I'm going to import that. So the smooth follow script you can attach to a game camera or to a camera, and it'll kind of look after the coordinates and all that stuff for you. So I'm going to go to main camera now and I'm going to add a script and I'm going to click on Unity Standard Assets and I'm going to click Smooth Follow. So the one thing about Smooth Follow script, it has this target, so you're going to have to drag whatever the game object that you want to follow, you're going to have to drag that around. So I'm just going to drag that into target. I'm going to hit this, and then I'm just going to change the rotation damping to 1 so it rotates as well, and then I'm going to play it. And so now we should have, so you can see how the camera is now rotating in the bottom. So if I want, I can change the distance obviously if I want to kind of zoom in, so it's more like, and I can change height as well, so it's more like kind of stuff like that. You can take control of that. So that's kind of closer to kind of a first-person shooter or something if you wanted to create that kind of idea. So that's two kind of basic approaches to movement. I'm just going to get rid of this one, or I'm going to pull the camera back further. Sorry, I'm used to using a much bigger screen. Kind of real estate is important when you're doing the game stuff. So it's kind of, that's big screen, but this is kind of, the ratio is kind of skewed. Okay, I'm just going to figure out here for a second why this camera angle is so far back. So I'm going to go back to the main camera. It's because it's there. It should be. I can't obviously move it. It's a Z. So let me just change. Reload all.
Well, you have to put in
Yeah.
-5.
Yeah. So now it should be further back when I play this. Yeah, so that's better. Okay. And I'm just going to actually increase I'm going to push up the y-axis, so I'm going to say, so one thing you can do is if I want to get a particular y-axis for the camera, I can say I like it up there, 2.25, so I can just go to the script and I can just leave it at 2.25. So that would be 2.25 there, or I could put 2.25 in there as well. I'm just going to change the coordinates of this ball again because it's too big. Okay, so that's movement, so that's straightforward enough. And the first person camera is taken care of there as well. So this brings us to collisions and triggers. So how you can detect if an object collides with something else. So obviously this is a huge part of any game mechanics. And this is how you, like, for example, pick up tokens, or how you might shoot an enemy, or how you're going to interact with other people as well. So each time we populate a scene with a new game object, Unity will automatically attach a collider component to that object. And then we can use that collider component to determine if it's collided with anything else. So there's two main types of collisions. One is a straightforward collision, and the other is some kind of a trigger collision. So when isTrigger is ticked in the collider property panels, collisions are going to be set up as triggers. So I'm going to have to, in order to demonstrate this, I'm going to put in another game object. I'm going to put in a cube. I'm going to drop it over here, for example, and just push it a little bit further away from the ball, so I can actually take a good run at it. Okay, at the moment you see that the box collider is set. There's no isTrigger set. Okay, so what I'm going to do is I'm going to click isTrigger. What that does is, if I now move the sphere and I collide with that box, it's going to trigger a method in my script called onTriggerEnter. So onTriggerEnter. So I'm going to go back to the ball script, the ball controller, and I'm going to create an onTriggerEnter. So void onTriggerEnter collider, and it's going to pass the object. It's going to pass information about. I'm not going to call it game object. I'm just going to call it game object. So the information that's passed to this method is going to be the instance of the object I've collided with. So I can do things. For example, once I collided with that object, I could have it disappear or something. If it was a token, or if it was like a coin in Mario or something that you had to eat and make disappear. If I just do debug log I hit something here, and then I play this. So I make sure on my cube I've got isTrigger. So, and then I'm just going to play this. So, and now as I move towards the cube, yikes, I hit something appears here. So I'm just going to clear these messages here. The debug log. So if I slowly move towards the cube, as soon as I hit it, then we get this. So obviously you could attach some kind of sound or something to the collision in that collision method. Something else, as I mentioned, you could do. I'm just going to slow down the speed of this. You could, for example, I could do something like destroy, and I could do game object, and that'll kind of destroy the object. So as I collide with the object, it's going to remove the object, that particular object, from the screen. So I just slowly go at it, and then it gets rid of it. So if you were using this to kind of pick up tokens or special objects and things like that. So it's handy because you can get all the information about the object that you collided with. So you could potentially change the color of the object you collided with. You could change the shape of the object you collided with. You could make it bigger, you could make it smaller. You could have it move anywhere across the screen. So it's kind of nice how the information is passed between the different game objects. So that's one type of collision. The other type of collision, I'm just going to take off the destroy thing. The other type of collision is what's called an onCollisionEnter. So when the isTrigger attribute of the collider at the moment is disabled, then the game object when they collide with each other, they're just going to do so as they would in the real world. So as one object hits another one, it could potentially move the other object. So it's going to use, whatever physics thing is attached to it, whatever its mass is, and the speed and the trajectory, the velocity of its movement, will be used to move the other object around the place. But so it will collide with the object, but as it collides, it will also trigger an event called onCollisionEnter. And so I can create one here on CollisionEnter, and it takes a collision, and I'll just call this game object as well. And I'm going to do debug log hello. Come back to the game engine. So I'm going to click on this cube. I'm going to turn off isTrigger because isTrigger is that's going to help it behave as just a kind of a trigger rather than some kind of physical object. So if I now collide with this object, now we get hello, and because the object has a greater, it's not going to move because I don't have a rigid body attached to the cube, but if I attach a rigid body to the cube as well, I can do that. Physics, rigid body, and then when I click it, it should kind of somehow move it around because it now has some kind of physics attached to it as well. So there are two kind of, I'm just going to get rid of that because I don't want it anymore. Remove component. So that's how you're going to look after collisions with different objects. So, and that kind of takes us then to the audio part of Unity itself. So, in Unity you've got the concept of audio sources and audio listeners. An audio source is used for playing back audio. It's a component that can be attached to any game object. So any cube or character or sphere or anything you've got, you can attach a particular audio source to it. In order for an audio source to be heard, an audio listener has to be somewhere in the scene. Okay. Audio listeners are usually attached to the main cameras, and actually Unity sets up an audio listener that's attached to the main camera by default in each scene. So while you might have 10 or even hundreds of audio sources, you can only have a single audio source per scene. Okay, which makes sense because you've only got one set of ears, you know. So you can you could attach the audio source. So I'll show you how you can attach it to the game player, and then as they move towards, or attach the audio listener to the game player, and then it'll act like local ears. So as you move towards objects, you'll hear things getting louder and quieter. The audio sources are pretty straightforward as well. So I can attach, let's say I attach an audio source to this audio source. Okay. And now you can see it's got this kind of thing around it, and we've got this new audio source inspector properties thing here. So I can click, I can bring in a clip. Let's just see if I can find some music. Well, I know I have music here, it's just I don't want to show you some of the really rough stuff. I will take, let's see. I'm just looking for some simple samples. 120 BPM loop. I don't know. This could be rough. I'm just going to copy and paste that into my folder that I'm working in. It's Csound 30B assets. Now, what I'll do here first is I'll just create an audio folder for all my audio. I'm going to rename that to audio, and then I'm just going to drop that file into there. Okay, so 120 BPM loop. So if I go back to so actually one thing you'll notice is you'll see there's this kind of speaker symbol around any audio source in your scene, so you can quickly see if it's an audio source. We click there, and I'm just going to drag that loop onto this. So, I can play it, I can loop it, and I can play it on awake, so as this starts, so we get that loop going straight away. If I don't have play on awake, and I don't have loop set, then obviously when we start the scene, we're not going to hear anything at all. So let's just have that sound happen as soon as I collide with the object, with this object in front of me. So the easiest way to do that would be to go back to my script. Up here I'm going to create private audio source. I'm going to call it audio source. In here I'm going to get that audio source equals get component. And then I can do something simple like on trigger. I actually set up as a collision at the moment. I can do audio source play. And now when I go back and play this, you can see that. Okay, something interesting happened there. You think, okay, Rory, it started playing, but it didn't hit the cube, but actually hit the floor. So there was a collision because it dropped. The ball is a little bit off the ground, so gravity dropped it towards the floor. When it collided with the floor, then it triggered the sound to play. So what I would do here is I will check. This is called cube, so I can check the name of the actual game object. So I can say if game object tag, is it tag or is it game object name is equal to cube, then I can play the audio source. So hopefully this should, if I've thought about this correctly, it should only play the audio source if it hits the cube. So let's play it. Now we get no sound, but now we get the sound, so the sound starts. So actually that brings up an interesting issue or point as well, that like you can put a different name on your audio source because you might have several different types of cubes, so I might call that one a music cube or something like that, and then I can check to see which object is after hitting on the screen. So let's say, for example, I'm going to take the audio source off this and I'm going to put it on the cube instead. Okay, so I'm going to remove this. I'm going to put the audio source on the cube. Audio, where's audio? And audio source is going to be in the cube. Okay, and I'm going to change the listener from the camera. So we can see there's an audio listener here. I can remove this component. And I'm going to put an audio listener on the ball. Audio listener. Okay, so you can see that the audio source has this kind of ring around it. Okay, so this determines the, if you like, the distance that you're going to have to travel to in order to hear it. If I increase the maximum distance, minimum distance, you can see that this gets bigger and bigger and bigger. So as the ball moves towards this, I'm going to make this like 0.5, which we might not hear at all, but you should get the idea. And sorry, I'm just going to make sure that the audio source on this plays straight away. So it is playing at the moment, but we're not hearing anything, and I'm going to make it loop as well. So we're not.
There's no audio source.
Huh?
There's no audio source. Audio clip.
Sorry, audio source, audio clip. Sorry, yeah, 120 BPM. But actually, that said there is no audio source attached to the sphere object. Oh yeah. I can take out this stuff because I don't have an audio source here. So now when I play this, so as I get closer to this, it should get louder and louder and louder. If I go further away from this, it should get quieter and quieter and quieter. It's not quite working out. Let's try it again. Let's make this smaller and smaller and smaller. Minimum distance. Play and awake. Let me make my world a little bit bigger. Okay, and I'm going to zoom out and I'm going to move the sphere. That's the wrong thing. I'm going to move the sphere further and further away from this. And I'm going to move the cube to the far side. Okay, so just going to double check here. On the sphere is the audio listener, that's fine, and on the cube is the audio source, and I'm setting the minimum distance to be quite small, and the max distance, I'm going to bring down the max distance to be 20 or say something like 2. Okay, so now hopefully we shouldn't hear this audio start, or maybe just hear a little bit of it. It should be louder. You can see what's happening here on this thing here. Okay, let me. Okay, we can kind of see it if I bring this down. So I can change it here. It's not. Need to delete some stuff. Flat. Okay. Anyway, right. The idea. I think you understand the idea. If obviously I'm doing something wrong there, but. The audio listener, if it's attached to the game object or if it's attached to the player, then you should be able to move around the scene. Actually, I've got an example of it in a kind of a simple scene in a moment, so we can see it there. But so you could attach audio sources to different objects in the room, like the speakers. So, and if I'm an audio listener, as I move towards the speaker, I'll hear it louder and I'll hear it quieter. So, so that's kind of they're the two kind of audio stuff that we see a lot of in Unity. Which brings us nicely to the next bit, and that's kind of, I suppose, why people are here, and that's CsoundUnity. So, the CsoundUnity package, it brings power of Unity directly into Unity, or power of Csound directly into Unity. So, each Csound, when I started CsoundUnity, I showed it to some of you in St. Petersburg last year at the Csound conference, and I thought, oh yeah, this is really cool. Like now we can use Csound in our games. But there was an issue. So the thing was that you had to disable the audio from Unity, and you use Csound to stream all the audio to the hardware. So you were using -0 ADC or DAC. So you were using the Csound audio I/O interfaces. So this was cool at the time, and I thought, yeah, it's not really a problem. But then I started to do a little bit more with Unity, and I started to see like it's got some pretty neat things for 3D spatialization and reverb areas and stuff like this. And I thought, okay, well, there's no point in trying to like write Csound code that will do all of the spatialization stuff and all this 3D kind of diffusion when it already exists in Unity. So I went back to it, and I had a look at a little bit more into how Unity works, how audio works in Unity, and I was able to turn the kind of my Csound Unity class into an audio source itself, which is a much better approach. Because then once it's a source, then I can use all the 3D positioning that's available in the audio source inspector on any Csound instrument that I use. So each Csound Unity component can compile a single Csound file, but you're not limited to the number of Csound Unity components you can use. Okay, so you can potentially have a different Csound instrument on every object you have in a room or in a scene. And because each Csound Unity component is an audio source, users can take advantage of the 3D audio options that I absolutely did not demonstrate very well in the last kind of section. But they do work. So the first thing you want to do, if we go to to the GitHub page, I have just 2 days ago I put up another release there. Currently I don't have an OS 10 package just for that version, but there's OS 10 packages for all the other versions as well. But actually all you really need is just, I can show you, all you really need is just this code. You just need these few Csound Unity scripts. So there's a few scripts in there. There's a Csound, C#. I have to say that a lot of this stuff I borrowed from the work of Richard Henniker, and he had created a .NET wrapper for C# wrapper for Csound. And he was great. He helped me a lot at the start. It's because there's some certain things you have to do to kind of get the C kind of host API into C#. So eventually with his help we got it going. So that's the main Csound C# interface. The Csound Unity class itself, that's the main class. So we can see in here, you've got your Csound file, you've got log output. So you've got the Csound Unity bridge, just like so that provides the interface to Csound. If we scroll down, we can see that there's this is going to create a new instance of Csound for us. In here, we're automatically setting all the channels at the start. And then if you scroll down, you'll see stuff that you kind of recognize from the API, if anyone's used the API. So you've got like set KR, you've got, there's a process block. So in the process block, what I do is you get a float vector of samples, so you get the number of channels. And in here I'm calling perform KSMPS, and then I'm using set sample. So, and I can take information, I can take audio from Csound and I can pass it directly to Unity, and I can also take the clips that someone might have dropped onto Unity and I can process them in Csound as well. And then down here you've got other things like perform KSMPS, get KSMPS, get sample, set samples. So this is how I'm setting the samples, how I'm filling the buffers. And then you've got other things like set channel, which is quite important for the channel routines. You can set string channel, get table, samp, stuff like that. So anyone who's used the host API would be kind of familiar with a lot of these methods. I just provided a C# interface to them. So I'm going to import the Csound package now by going to Assets, Import Package, Custom Package. I'm going to go to Source Code, and I'm just going to select this one. This one is, so I'm just going to need this one, it's Csound Unity Bare something actually I did prepare actually for this, and all it is it's the entire Csound Unity package minus the actual games and the scenes that are in that package. So I'll show you that package later, but just simplify things now. I'm just going to bring in what I need, which is the scripts. So this is what gets imported. We can see here all the plugin DLLs. Here's your scripts. And also there's a thing up here, an editor. So this is something that was born out of some work I was doing on another project. And this kind of provides a few little bells and whistles to the interface, which I'll talk about again. So I'm just going to hit import. That's going to import all the objects, everything I need. So now I'm going to get rid of this audio source. I'm going to go put it back, remove component. I'm going to put the audio source back on the camera for a moment. Audio listener. There it is. And I'm going to go back to my cube. Sorry, my sphere, it's the main player. and I don't have an audio, so I'm going to take off the audio listener here. Now I'm going to go to add components. Now when we go to audio, we can see we have a CSoundUnity component. Okay, so if I want to, I can just simply add a CSoundUnity component. Okay. Next thing over here in the assets, I'm going to go to scripts. I'm going to create a folder called Csound files because I'm super organized. CSoundUnity will look for files in a folder called Csound files in the scripts folder, or else it will look for Csound files in the actual scripts folder itself. The reason why they have to go into the scripts folder is because when you export this as a game, Unity, the game itself, has no concept of local file systems. Everything is standalone in the game. So we have to set everything up relative to the project root. But if you just keep them in there, that's fine. So I'm going to open up, I'm just going to...
Yeah, so is it hard, Csound files, names Csound files hardwired?
no, the path, just the path, yeah.
But it has to be called Csound files.
No, you can call it anything. Sorry, the folder. So you can either put it just into the scripts folder as is,
yeah,
or you can put it into a folder called Csound files.
and it has to be called Csound
It has to be called stuff, yeah. So it's just for organizing things a little bit better, yeah. So I'm just going to create a new cabbage effect. I'm going to go to source code CSoundUnity assets scripts Csound files, and I'm going to call it ball controller, and I'm going to save it. Okay, and I'm just going to get rid of some stuff here, and I'm going to get rid of some stuff here. Okay, I'm going to save that. So I'm just going to create a simple instrument here, instrument 1000, and then just do something really simple. Sorry, I'm going to just change that to a whatever env. And save. Okay, so I'm now going to close this. So that sets us up. So in the audio in, let's see, Csound files, now I've got this ball controller. Okay, so if I go back to the sphere, which is my main player, if you like, down here, because I've attached the Unity script, well, the first thing is once you bring in this Unity script, it's automatically going to create an audio source because the two have to exist together. So, but you don't have to do that yourself. If I just drag this ball controller over to here where it says drag and drop Csound file, and now I've got this script attached to this particular game object. So if I enable process clip audio, then it's going to route whatever audio you have in the clip through your Csound script as in CH, so you can kind of do processing of sounds that are there. So if, for example, you had some loops and you didn't like the reverb that Unity provides, you could use any of the reverb outputs in Csound to do that yourself. You've also got, there's a mute Csound and there's a log Csound output. If you log Csound output, for example, if I play this now, if I save this and play this, obviously nothing's going to play because I haven't triggered that instrument to play. But we should see down here a kind of familiar kind of set of Csound output and stuff like that. So again, Csound isn't communicating with the hardware, it's all done through the audio interface in Unity. So if I want to, say, trigger that instrument to play, I could go back to my script, reload all. I can, up here, so I'm going to create a new private Csound Unity object. I'm going to call it Csound. And then here I'm going to just say Csound is equal to get component CsoundUnity. That's going to give me access to that particular component. And then on collision enter, I'm going to say if again game object name is equal to cube. So what am I going to do now? So now I'm just going to call, for example, I could do send score event. So I can call instrument, I think I call it instrument 1000. I can set it to play straight away and play for 10 seconds. Okay, so now when I go back to Unity, you know what, because this is just going to blow your minds, I'm going to go to maximize on the screen, you know, so we can get the full cinematic effect of this ball hitting this cube. Oh, well, that's an anticlimax, isn't it? Okay, maybe the collision isn't taking place. There's a chance that the collision is not taking place. cube. Let me just go back. I'll just do it on a trigger enter, and there should be any issue. It was instrument 1000, wasn't it? Let's see. I'm just going to open it up. Instrument 1000. Back here. Well, that was a real good fail, wasn't it, in fairness? Csound 30B assets, scripts, Csound files, ball controller, instrument 1000. Is there actually something? Is the instrument okay? Actually, the instrument should be fine, right? Yeah, that should be okay. Yeah, okay, that's okay. Let me go.
Look at the messages.
Yeah, that's a good point. Yeah, it's just the screen is so small. That's the thing. Okay, I'm gonna have to turn off maximize. Sorry, we can go for a full cinematic effect later, but right now it's more important that we see what's happening with the messages. Okay, so so actually I want to turn this sphere at the moment is still. I'm going to put it into is trigger or in trigger, and then come back here. It's eventually going to hit it, and no, it's not triggering anything to happen here. Let me double check. Oh, I think I know what the problem is here. Sphere.
The output, is it?
I'm going to bypass all of this stuff. And the output, no, the output should be okay. I think it's just that I have, and then 3D.
It's not that the events not being triggered, because you see that there's no...
I know, there's nothing happening there, but that, let's see. It's just going to make sure that this is working. Debug log. And come back here. I'm going to change the cube to be as a trigger, and I'm just going to move the sphere a little bit closer so we don't have to waste time following it all the way there. So we should, when the sphere hits here, we should have at least hello. But it's not triggering anything to happen.
It's the...
Let me try and just put in an event from the start. We should hear something. Instrument 1, 0, 10. So this should give us at least, as soon as we start, we should have at least some sound.
No, that is instrument 1000.
Sorry, instrument 1000, yeah. Okay, and instrument 1000. Is the audio off?
Could it have anything to do with
No,
your
it's not
distance,
It's not listing there.
silencing everything on your far away?
But the audio, no, that should, I'd say that should be different now again. There's a ball control. Okay, that's working.
So when you're running it, it's not... but it's not really showing any of that playing there. Like
No, I know, yeah, that's... But actually, let's see, I'm going to turn off. Perhaps it's not picking up the CsoundUnity, which we would see here then, if it can find that.
But it was logging something, so it's actually running. Maybe
Yeah.
not running the right file. Or
No,
it's
it can't not run the right file, ball controller. And it's processing clip. It should say, actually, we should see when I log the output. This is just something silly that I'm doing, obviously. It should say that it's loaded that up for real time, and it should say the name of the file, right? At the top here. That's the unified ball
You
controller.
have to run the processing, because it does look like it's not actually getting into the co-process Csound or something. Do you need to do anything like that?
No. Instrument 1000. It's going to play. I'm using, like, instrument 1 is running the whole time, so.
And what I'm saying is that what looks like it is compiled, but they're actually not running.
Yeah, like perform case MPS isn't called.
Yeah.
Yeah. But it's it should be.
Because if it was, you would have instrument 1 appearing there as an allocation.
Yeah.
New allocation.
Yeah, it should be down there, but
Is there anything you need to do to start
No.
to make it?
no. Logs. Let me, I'll tell you what, just to make sure that there's nothing odd happening, I'm going to open up this,
One that I prepared.
something that I prepared earlier. Damn it, I think I have to get to this. No, I just want to check, because this one here is using the exact same DLL, same everything, so if this works, well then it's obviously something stupid I'm doing on the other side, so yeah, so that works. This is what I imagine if Cabbage was like down the roost and had a few pints and he'd relieve himself on the way home. So that's obviously working. So there's something something stupid here, something really silly. Something is wrong. Do I have an audio source in there? Do I definitely have, or an audio listener? Do I definitely have the audio? And is it actually on? There's the audio listener, yeah. Okay. And the audio source, perhaps. So I'll go back to Cube. I'm going to set the sound again to be 2D. The pitch is 1. Okay.
Yeah, it's working now.
Yeah. So now I should have.
What
So,
happened? What did you do?
It was 3D space.
the 3D spacing was set to 2D. Was it? Or I had it set to 3D.
I said that.
Oh, sorry, you said that. Oh man.
So what was it?
Sorry, I had this set to 3D, so it was outside the scope of the listener area. So I think that was something like that was
So you
happening.
weren't listening to it. It was
So
playing,
it wasn't. It was playing, but we weren't listening to it. But so I'm just gonna.
But it wasn't playing because it never showed your location there. So it was never.
He was outside here, so he's having a phone.
I think that's what's happening. Yeah. It was outside
Even
the
before
area.
the processing. Because that
Yeah, you're right. You're right. I don't know. Actually, you're right. Yeah. So that wouldn't have made a difference. So thanks for your suggestion.
So what
But
is it
it was wrong because you're right. Like what we didn't see was new allocation for instrument.
we never saw that.
So
How come you fixed it without?
I'll tell you. I think I know how I fixed it because I opened up Cabbage to generate the instrument. Cabbage hooked into the audio, the ASIR, the win, whatever direct sound. And I think sometimes that takes away, then it robs the focus for the audio from Unity. And if I restart Unity, then I get the audio back. So,
Windows.
yeah. So, anyway. So we have two things here. I'm going to change this back from being a is trigger, and now I should have sound at the start. And I should have sound when I collide with this. Okay. The Angelus. Yeah. Okay. So yeah, that's really kind of basic, simple thing. If we wanted to, let's say, control some stuff in real time, we could, for example, if I go back to the Csound file, and let's say, well, one thing what I like to do as well is if I'm kind of doing some sound, I'll create something like a button, and I'll create a channel, and I'll call the channel trigger audio. Okay, and then in here I'm just going to use I'm going to do k trig chan get button trigger audio it's called, and then I'm going to do if changed k trig equals to 1. So I'm going to basically check and see if that channel changes, then I'm going to trigger the instrument to play. So I'm going to do event and then instrument 1000, 10 seconds. Okay, and I'm just going to take off this event here because I don't want it to play from the start. So as you've seen, I can just send a score event to trigger any instrument that I want. Okay, but in this case, I'm going to just trigger the instrument using the channel. So why I would do this is when I go back to this and I click on my sphere here, and I scroll down to this, I now have this thing that says trigger audio down here. So as I press this, now I can trigger the audio. So I can kind of audition the sounds without having to have the events take place in the game, which is kind of nice for sound designers they just add in a new channel in the cabbage syntax. It's not. It's just. I mean, you don't even have to technically write cabbage up here. You can write, I don't know, lettuce or like whatever, Brussels sprouts. It doesn't matter so long as it's just in that little bit at the top. So, and what's happening is when I trigger this button, it's changing the value of this button between 0 and 1, and as it changes, then I can trigger sound. Of course, I get the exact same effect if I collide it with the object. Except when I collide with the object, I'm sending a score event. Okay, so instead of sending a score event, I could do something like Csound set channel, and my channel is called trigger audio, and I can just do something like random range, and I can just do 10 to 100. So every time this event is called, I'm going to generate a new random number. Every time I generate a new random number, this changed opcode is going to return true. It's going to return 1, and then it's going to play the event. So in this case, I prefer to use channels because I can set up the channels to behave in the same way that my buttons do. So, and I can also trigger that from here. If I wanted to get real-time information,
So why the random?
Why did I use a random?
Yeah, the random. What's that random doing?
It's sending a random value to the channel.
So we not the same as the previous random.
So it's not, no, it's always taken from it's going to be seeded correctly. So basically I want to ensure that every time I hit the object, then it's going to send a random value to this channel, and then I'm going to see if it's changed. If it's changed, yeah. Or I could just like have a variable that goes between 0 and 1 or 0 and 1. So. If I want to send real-time information to the instrument, so I could do something like
Rory,
yeah.
just you could have changed trig back to 0 when it trigged, and then you didn't need to change one value, just change just.
Oh yeah, use a chan set.
Yeah.
Yeah, that's right. Yeah, I could do that, so.
Like when you say chan get, could it be chan get, and you always send 1, and when it's changed, then you send
Just
it back
reset
to
it
0.
back. Yeah, that's right. Yeah, it would work as well. If I want to do some kind of real-time control, I'll just do something really simple, like I'll do chan get k freak and outs A1. So instrument 1 is running all the time. We're not using this instrument anymore. Get rid of it. Save that, and then if I go back to my scene, so what I want to do is, I no longer want to do something on a collision. I want to actually have it update. Let's say I use the player's position to control the pitch of the instrument. One thing I want to do is just check and see. It's got quite a runway here. So on the sphere, I just want to check the transform. So the z-axis goes between 13 and kind of minus, let's say 13 and minus 13. So I'm going to plus 26 to that, and I'm just going to do Csound Unity. What did I call it? Csound or Csound Unity? Csound set channel, and then I'm going to do freak, and then I'm going to do transform. So the transform will get the transform for this particular object, position, z plus say 26. That will kind of more or less scale it between 0 and 1, and then I'm just going to multiply that by my max frequency. So I'll multiply it by 500, for example. So now I'm going to take the sphere's z, so that's kind of on this axis, and I'm going to use that to control the pitch of the simple little file. So when I play it, whoa, sorry, not quite. I didn't quite scale it right, as we can see. So where's that going again? Sphere is going between. Oh, it's minus a third. Let's do something less. So if z is going between minus and plus 13, right? So when it's minus 13, it's plus 26, so it should be 13, and when it's minus 13, it should be, yeah, right? So let me just bring it down to 10.
No, it's minus.
Okay, something like that. So now we've got the real-time information coming from the game object, and then we can use that information in any way we want. That's kind of it. I'm just going to show you a few more examples, but that's kind of basically how it's quite easy to get this going. Like I said, you can attach a different. Well, I'll just show you for some examples. It's easier. If I go to Csound, so this, if I don't need to say that. When you install the package, if you select install everything, you'll get this. So you'll get basically CsoundUnity package. You'll get some scripts, and you'll get some demo scenes as well. So we saw the first scene in here. So scene 1. So this is where cabbage is. Oh no, actually this is a different scene. So in this one, I can move. So cabbage, I can turn around. I can press spacebar to launch a missile, and then I can. In this, what's happening? Oh yeah, that it automatically stops the audio when you lose focus, but I'm just going to turn that down. In this one, what's happening is I've created all these little columns. I've got an invisible wall in front of this. When I throw a missile, which is that little thing over there, I'm just cloning that little green ball. When I throw a missile and it collides with the invisible wall in front of it, I just take the position that it's hit the wall and then I push the column up. And then as the column comes up, I'm also setting, I can show you the actual scripts for this, or the Csound files for this. It's quite straightforward. CsoundUnity, assets, scripts, Csound files, and I think this is called harmonic. So I've just got this simple little instrument called harmonic. When I instantiate the instrument, so I just instantiate this instrument every time there's a collision. I'm just using a send score event, and then I'm basically setting the frequency and the amplitude depending on which column it's supposed to bring upwards. So that's fairly straightforward. If we see in the player controller, we should probably see in the player controller, actually player controller isn't doing anything to do with audio, it's to do with the wall. Let's go back to the wall controller, actually it's in the column. So each of these columns has a Csound script attached to it called harmonic.csd. And I'm basically just instantiating that then. When a collision happens with the wall, that's when a ball hits the wall. We should see here I'm creating. Sorry, just get rid of all this. Go away. So I'm doing get column controller, and then I'm doing this. I'm calling this set amplitude. Set amplitude is a member of the column controller, and that's going to set the amplitude for each of the. So each column controller has a unique frequency attached with it. From this script, I'm going to set the amplitude of each of those columns depending on where the ball hits the wall, and that's going to bring up the amplitude, and that gives us that do kind of sound.
So do you have multiple Csound objects then?
Oh yeah, I've got in this case I've got 15 different Csound instances.
Why?
That's just easier. I just put so I've got that little script.
You have one and then 15 notes.
I suppose I could do it that way as well, but I just thought it'd be easier just because, well, if I just have one and each one of these has a Csound thing, then I just clone it, and I can use the exact same methods for each of it.
But it's like there's a lot of overhead in.
Yeah, perhaps. Yeah, you know, you would like, for example, I'll show you in a moment a kind of a more involved game, and that's I keep most things to one Csound instrument. It just makes things quicker. If I open up the other scene, scene 2, in this scene, so you can see that the listener is attached to the cabbage, and then I've got all of these, and these are they're using the same Csound file. And they're audio sources, and we can see they've got a particular kind of area, so you have to enter that area to hear the sound. So I can move around and hear. So, and as I get closer to different spheres, we're going to hear the tones of those spheres. I can jump, and it makes it doop. Yeah, and I can kind of move around. So again, in this one, each sphere has a Csound object attached to it. I'm just using a very simple instrument, that same kind of harmonic instrument again. The third example, cabbage on the way home from the pub, is a little bit more involved. In this one, what I'm doing is I've got some random noise. I'm writing the random noise to a function table that's got 62 indices, and then I'm grabbing in my Unity script. I'm querying the index value, I'm declaring the value of a particular index in the function table. That's what's creating the EQ effect that we see. So it's kind of a real-time spectral kind of visualization thing. And then when I lob a cabbage tennis ball thing at it, where I've got loads of, I've got bandpass filters, and I'm just increasing the amplitude of the bandpass filters at those particular bands, so I can do. So I'd started another example actually where it was kind of fun as well, but I never finished it. Where you were a sniper and you could take out frequencies, in the distance from an FFT mountain, so you could shoot out different frequencies. So that was a bit fun as well. So I'm just going to show you something that I was working on for a few days. I'm kind of hesitant to show this because it's completely unfinished, but perhaps it's interesting because you can see the approach I would take to doing something a little bit more involved. So I've got this instrument here. What I normally do is I build all my soundscape and all my sound design. I do it with the cabbage first, and I have kind of graphical ways of triggering the different things. So you got ambient kind of gain. I can take that out. I can turn this up just a little bit. And I've got this kind of generative algorithmic rhythms and stuff happening. So I can turn off that, and I can play, for example, music box 1. Or I could enable this, and when I enable this, what I've done is I've kind of shuffled loads of function tables with. If I can show you the code actually, if it's not going to. So here's loads of function tables that I use for the different rhythms and stuff like that. So you've got 16 different steps, and then you can shuffle them all. So each of these function tables relates to a sample that I've got on disk. Okay, so for example, sample 1, sample 2, sample 3, I'm using the FT sample bank opcode that I wrote because it's a really quick way of getting all that information into tables. And then the 1s and the 0s are going to determine whether it's going to play at that point. So think of this when I'm playing this Wonderland thing here. Every time I hit change, it's going to update these tables, and it's going to put 0s and 1s in there according to kind of random processes. So, and then as the thing is moving along, so if you like it, there's a kind of a scrubber that it's going to play all of these notes. If they're all on, it'll play 16 different samples at the same time. If there's a 6 on, it'll play 6 at the same time, so you can kind of build up chords. And then, as I said, you can change the tempo, so it goes a little bit quicker. And every time I hit change, it's going to change the rhythm. So it's kind of subtle. I mean, percussion you can hear as well. It's just, so these are sounds that, most of the sounds were recorded. So for example, that's the basic. So if I hit change, then it's going to change the rhythm of it. So the weight, so I can kind of, the random probabilities that it's going to populate the table with hits can be changed and stuff like that. So the idea was that I was going to use this in the game. And that every time you play the game, the audio is going to be different. So it's kind of generative kind of ideas. So and there's all these different things. For example, this stuff, all this kind of stuff. The nice thing about this is, well, I'll show you the game now. I'm just going to reopen the game, and it should, because I'm restarting Unity, it should be okay. So so I had an opportunity to spend some time in Lough Dan at an artist residency there last summer. And myself and my wife, we were expecting our first child at the time, and we were. My wife was sure it was going to be a girl, so we thought it would be nice to build a small little scene or a small little game for our baby daughter. His name is Mo. So yeah. So anyway, so this is the game that we were like. As I said, kind of reluctant to show it because it's really unfinished. It's really rough. But my wife is a visual artist, and so we said it'd be nice to kind of work on something together before family life takes over, and we're suddenly, we don't have time to do any of this anymore. So I can play the game. Let's see. Yeah, just play it. So Csound is running. So everything you see is all generative, like the leaves. I'm using different kind of generative algorithms to animate the leaves. I can click on these orbs. It's going to create that. Watch out for the fox. He doesn't bite this time, but he could bite. If I go into the water, So we recorded all these sounds in Lough Dan, in the hills and by the lakes and stuff, so it was nice. And go back to, basically I can't get through that water. This is kind of a spoiler, but if you ever play this game, you have to let the sheep out of the hut. And then once the sheep get in there, then you can just walk across the top of the sheep. Well, I actually put in a cheat as well yesterday where I don't need to hit the ground to jump anymore. And as you get to these different objects in the game, they're going to trigger different instruments to start playing. So for example, when I get up here, and then if I walk across here, get the sound of that, and then water comes down, and then it's going to trigger different sounds to play, and it's going to, so in all the time as I'm moving through the scene, there's different events that are triggering, updating the background sound and stuff like that. So we've got some pillars here that are going to be moving and stuff. I'm just going to bounce over them, sorry. You can't do this in the proper game because, as I said, you have to be grounded. So in here I've got some audio sources attached to these blue bells, kind of they're creating that bell sound. This part is quite tricky to play, so I'm just going to cheat. And I'll just spend my time up here actually. Oh, that's what I didn't want to happen. And so on and so forth. You get the idea. Hours and hours and hours of frustration. Yeah. So, thank you very much. Does anyone have any questions?
Guns and all kinds of things for Mo now, though. Instead of
yeah, I know. Yeah. Some guy's going to appear with a rocket launcher. Yeah, and there'll be like Apache helicopters.
Armor.
Exactly. Yeah.
Sword, shield.
But really, I mean, it blows me away that when I use so just to kind of finish the, we run a composing for games course at the Dundalk Institute of Technology where I work, and I had to teach a module on it 2 years ago for composing for games, and so I was using the audio middleware, and I found it kind of frustrating because I thought the audio middleware is a little bit limited. So that's why I did this, and then actually it turns out that I tried to do this for Unreal Engine as well. I was telling some of you about it last night, and it was really hard to bring. It's not hard to bring Csound into Unreal Engine. It's really hard to get reasonable latency and quick so. They've got all sorts of things for really quick streaming, but none of it seemed to work. Eventually, I did get some kind of quick bing, bing, bing sounds, but there was other problems then with other stuff, and I got really frustrated. So I wrote a Csound plugin for Fmod, which is it's an audio middleware, quite popular, and that means that sound designers can work in a kind of an engine agnostic way because they can do all their sound design in Fmod, which is just like a DAW. And then they can export and they can bring it into Fmod or they can bring it into Unreal and all this kind of stuff. So I would personally to be just accessing Unity directly within the game engine. But if you have students that are more, that are kind of a little bit afraid of scripting and stuff like that, then they can certainly use Csound within Fmod. And this summer as well, I hope to write the WISE plugin as well, so you can use it within WISE, and that way you can bring it into any game you want. So. Does anybody have any questions? Or?
So the latency here is not too bad.
No, it's fine. Yeah.
And the other thing I was going to ask you, and that's because that example you showed me of the balls and going around and forth. Can you do out of Unity? Can you do virtual reality sort of immersive?
Yeah.
Because that would be really good for that type of thing.
Yeah.
So
absolutely.
instead of doing a game, you can do a composition.
Yeah.
That space and sort of.
Well, we have Kieran is a colleague of mine, right? Because we have an Oculus Rift in the university, right? And there's VR plugins for Unity. So actually, I was thinking when you were talking about your binaural stuff earlier, I was immediately thinking, well, we could use Csound in Unity, and you could be moving around in a three-dimensional space and exploring your synthesizer sounds and stuff like that, or anything that needs headphones and total immersion. So
Unity are pushing themselves, as kind of the OS of VR at the minute. They're really trying to go for that. So it would be the way to go.
Would be cool, yeah.
I think this also has got the potential to use it in a concert hall using ambisonics and making compositions where not the composition is around the listener, but the listener kind of moves around scenes.
Yeah.
And Yeah.
Certainly from your
It
point of view as
changes
an
the
architect.
approach to
Yeah.
composition, doesn't it?
Absolutely, yeah, I think so, yeah. But it is also, I think that the whole generative audio stuff, like I had a laugh a couple of years ago at the biggest game conference in the world, you know, the EA people nearly wet themselves with excitement because somebody had created some kind of generative thing for, I think in the latest Grand Theft Auto, for the spokes on the bicycle or something, you know, and it wasn't a sample, it's actually generated, you know. I was, wow, this is like, are you joking me, like all the stuff we can do with audio and you're getting wet because you can synthesize the sound of spoke, like, you know, this is like, considering what we can do with Csound, you know. So it's just, but I think it's all gonna take off, all the generative audio stuff, you know. Stephen posted something interesting on the list recently. Stephen, where'd Stephen go? There he is. About the way they're calculating reverbs in different scenes in the Gears, the latest.
Yeah, that was quite a demo.
Yeah. That's pretty cool. But like, and that's we can do all this stuff anyway with Csound. We just have to convince the sound designers and the game developers that they need to break away from the kind of restricted tools they're using and like free themselves, you know, and just use something like Csound where you've got total control over everything, you know.
Or hire us. You know.
Or hire us, yeah. I can be bought, like, you know. Put that on the tape. That's going on. Yeah. Okay. Thanks. Oh, sorry.
So your example showed creating game objects and attaching scripts to them, but it seemed like you also had game objects that were generated by scripts, like those leaves or the missiles, right?
Yeah. That's possible as well. Yeah. So for a lot of those, what I did was I created, like you might see over here actually, like, okay, here's some of my sheep. Actually, it's just one sheep. There he is, in high def. That's Sheepy the sheep. What I did was I create an instance of him. So whenever I have to use sheep in the scene, I basically just clone this one. Like, we should call him Dolly actually, because I keep cloning him, cloning her. Yeah. So, but you can generate anything you want. It would be more difficult for me because I'm still I'm not Unity expert at all. Like you can generate simple primitive objects like cubes and stuff like that. But if you want something a little bit more complicated, it's better to build it first and then just reinstantiate it throughout the scene. But yeah, you can also. You saw as well with the EQ and stuff like that. So you can send information from Csound. So I could use spectral information from Csound. I could use the presence of energy at a particular band to have a bad guy appear, you know, in the scene, you know, and we'll call it, he could be Mr. Frequency X, you know, and he could be a bad guy, and you don't want to meet him, like, because he comes in at 203 hertz or something, you know. So you could actually play all these, you could bring in all these interesting audio kind of elements to the game, you know, that kind of haven't really been explored, I think, in a lot of audio games. Okay, thank you very much.